There is a photograph taken from space that changed the way a small number of researchers understood everything. Not the famous blue marble, not the pale blue dot. A different image. An image of the Himalayas taken from orbital altitude in the late 1970s, when satellite photography first became precise enough to show the full branching structure of a mountain range in a single frame. One of the geographers who first studied this image put it down on his desk and placed next to it something that had nothing to do with geology. A photograph of a tree root system taken from directly above. Roots spread across soil, branching outward from a central trunk, smaller branches extending from larger ones, the whole structure reaching into the earth like a hand opening. He placed the two photographs side by side. The Himalayas and the root system. And then he did something that took considerable professional courage for a man trained in the rigorous discipline of geological science. He picked up the phone and called a botanist, because what he was looking at was not a geological coincidence. It was not a casual resemblance. It was a match. Not approximate. Not suggestive. Exact. The branching angles were the same. The scaling relationships were the same. The way smaller ridges extended from larger ones at the same ratios that smaller roots extend from larger ones. The fractal geometry, the mathematical signature of how the structure filled space, was identical. He had spent his career studying mountains. He had never once looked at them and seen what they actually were. And in that moment, staring at two photographs on his desk, he understood that nobody else had either. What he did with that understanding, who listened and who did not, and what it means for everything we think we know about why human civilization developed where it did and how it grew the way it grew. That is the story we are going to tell today. And by the time we finish, you will never look at a mountain the same way again. Let us start with what fractal geometry actually is, because this story cannot be told without it, and because most people encountered the word fractal at some point and filed it under abstract mathematics and moved on. But fractal geometry is not abstract. It is the most concrete thing in the world. It is the geometry of how nature actually builds things. In 1975, a mathematician named Benoit Mandelbrot published a paper with a question in its title that should have stopped every scientist who read it in their tracks. How long is the coast of Britain? It sounds like a question with an obvious answer. You get a map, you measure the coastline, you have a number. But Mandelbrot showed that the answer depends entirely on the scale at which you measure. Use a ruler 100 miles long and you get one number. Use a ruler 1 mile long and you get a larger number because now you are tracing around bays and headlands you missed before. Use a ruler 1 foot long and the number gets larger still because now you are tracing around every boulder and rock formation. The coastline gets longer the more precisely you measure it. And the relationship between the scale of measurement and the length of the coastline follows a precise mathematical law. That law is described by a number called the fractal dimension. Mandelbrot showed that coastlines, river systems, mountain ranges, cloud formations, snowflakes, the branching of blood vessels in living organisms, the structure of the lungs, the branching of neurons in the brain, the root systems of trees, all of these share this property of self-similarity across scales. A small piece magnified looks like the whole, and all of them have fractal dimensions that can be measured and compared. This was not a metaphor. This was mathematics. And what the mathematics showed was that nature had a preferred geometry, not the clean lines and perfect circles of classical Euclidean geometry, the ragged branching, self-similar geometry of things that grow under physical and biological constraints. The geometry of roots, the geometry of rivers, the geometry of mountain ranges, the same geometry, the same mathematical signature, described by the same fractal dimension numbers. And nobody in the mainstream scientific tradition had seriously asked why. The Himalayas run roughly 2,000 miles across the top of the Indian subcontinent. From the ground, they are overwhelming. From satellite, they are something else entirely. The central spine of the range sends subsidiary ridges southward and northward. Each of those ridges sends smaller ridges outward in turn. Those ridges send still smaller ones. and the whole structure branches down through scales until it reaches the individual valleys and gorges that a person walking through them would experience as separate places with separate names and separate histories. But from above, they are not separate. They are one thing, one branching structure. And when that branching structure is measured using the mathematical tools of fractal geometry, the dimension number that comes out is between 1.4 and 1.6. This is the number. Remember it, because tree root systems, measured using the same mathematical tools, produce fractal dimension numbers that cluster in the same range, between 1.4 and 1.6. The Andes, the longest mountain range on Earth, running down the entire western edge of South America, measured, between 1.4 and 1.6. The Alps, the Appalachians, the Atlas Mountains of North Africa, the Zagros Range of the Middle East, all measured, all between 1.4 and 1.6, the same number, across every major mountain system on the planet, the same mathematical signature as the branching structure of tree roots. This is not a visual coincidence. It is not a poetic observation made by someone looking for patterns. It is a measured, documented, reproducible mathematical correspondence between the geometry of mountains and the geometry of living root systems. And the mainstream geological explanation for this correspondence, the one that appears in the peer-reviewed literature when this finding is discussed, is convergent mathematical evolution. The same physical forces produce the same geometric solutions in different substrates. Gravity and erosion and the distribution of stress in rock produce branching in mountains, the same way nutrient-seeking and water-seeking, and the mechanical constraints of soil produce branching in roots. Same forces, same solution, different materials. This explanation is probably correct in its basic form, but it leaves something out. Something that becomes visible only when you stop looking at the geometry in isolation and start looking at what was built on top of it. Because here is what nobody puts together in the standard curriculum. Every human civilization that has ever mattered economically built itself inside the branching structure of a mountain drainage system. Not near mountains, not around mountains. Inside the branching geometry of the drainage basins that mountains create. A drainage basin is the area of land from which all water flows to a single river outlet. The shape of a drainage basin is determined by the ridgelines of the surrounding mountains, and those ridgelines branch with the same fractal geometry as tree roots, which means every drainage basin is shaped like a root system viewed from above, and every pre-modern economy, every ancient trade network, every empire that rose and fell before the Industrial Revolution, organized itself along the branching structure of the drainage basin it inhabited. The economic history of China cannot be understood without the Yangtze River drainage basin. The Yangtze and its tributaries drain an area of roughly 700,000 square miles. The branching structure of that drainage system, defined by the mountain ridges surrounding it, organized Chinese economic life for 4,000 years. Surplus rice production from the interior river valleys moved downstream along the tributaries to the main river to the coastal outlet. Trade goods moved back in the reverse direction. The whole economy flowed along a branching tree. The economic history of ancient Egypt is the Nile drainage basin. One river, one outlet. Every agricultural surplus produced in the Nile Valley for 3,000 years moved northward to the delta. The entire civilization was a single drainage channel, and the economy was the water that moved through it. Mesopotamia. The Tigris and Euphrates drainage basins. The first cities in human history, Ur, Uruk, Babylon, appeared at the points where the drainage network reached its densest agricultural productivity, not randomly, not by cultural preference, at the mathematically determined points in the branching structure where water and soil and climate conditions created the maximum agricultural surplus. The cities appeared where the root system said they should appear. This is where the argument becomes something more than interesting geology. Because if every pre-modern economy organized itself along the branching geometry of its drainage basin, and if every drainage basin is defined by the branching geometry of its mountain system, and if that mountain branching geometry matches the branching geometry of tree root systems, at a mathematically measurable level, then something remarkable follows. The economic geography of the pre-modern world was not the result of human choice. Not primarily. Human beings did not look at a landscape and decide to build their trade networks in one pattern rather than another. They were reading a document that had already been written. By the geometry of the earth itself. Every mountain range was a root system. Every drainage basin was a root's zone of influence. Every river was a root conducting resources toward its outlet. And the human economies that grew inside these structures were not imposing their own organization on a neutral landscape. They were following a template that had existed since the mountains formed, a template written in the mathematical language of fractal geometry, a language that roots and rivers and mountain ranges all share because they are all solving the same fundamental problem. How do you distribute a network through space as efficiently as possible? How do you reach every point in a territory with the minimum total length of pathway? The answer, whether you are a tree reaching for water, a river reaching for the sea, or a mountain range expressing the distribution of tectonic stress, is always the same. You branch. You branch with the same ratios. You branch to the same fractal dimension. And the human economies that built themselves inside these structures branch the same way. Local markets nested within regional markets nested within long-distance trade networks. The self-similarity of the fractal applied not just to the physical structure of the mountains and the drainage basins. It applied to the economic structure built inside them. Because the economic structure was not separate from the physical structure. It was the physical structure, expressed in human terms. Now I want to take you somewhere specific. I want to take you to the Mediterranean basin in roughly 500 BC. From above, from orbital altitude, the Mediterranean looks like a sea surrounded by mountain systems. The Alps and Pyrenees to the north, the Atlas to the south, the Anatolian highlands to the east, the Zagros and Levantine mountains beyond those. These mountain systems define a series of drainage basins that drain toward the Mediterranean, and the branching structure of these drainage basins, from above, from space, looks like the roots of an enormous tree reaching downward toward a sea that functions as the trunk. Or perhaps more precisely, like the root system of a tree seen from above, with the Mediterranean as the space directly beneath the trunk from which all the roots extend. Every economic network that has ever operated in the Mediterranean basin has followed this branching skeleton. The Phoenician trading network in 800 BC. The Greek colonial network in 600 BC, the Roman provincial economy at its height, the Islamic trade empire of the 7th through 12th centuries, the Italian merchant republic networks of the 13th through 16th centuries, all of them, every single one, following the same branching lines, because the branching lines were not a human invention, they were the geometry of the landscape, and the landscape was a root system. Here is the emotional truth underneath all the mathematics, and I want you to sit with this for a moment because it is genuinely staggering when you let it land. Every great city in history was located where the root system said a city should be. Rome was built at the first place upstream from the Tiber's mouth, where a river crossing was possible. The Tiber is a tributary of the central Italian drainage system. The central Italian drainage system is defined by the Apennine mountain range. The Apennines branch like a root system. Rome was not chosen by its founders for arbitrary reasons of sentiment or tradition. Rome was located at the mathematically determined optimal point in the branching structure of its drainage basin for controlling the movement of goods and people between the interior and the coast. The same is true of London on the Thames, Paris on the Seine, Baghdad on the Tigris, Cairo on the Nile, Chang'an, the ancient capital of China, in the Wei River Valley, at the junction of two major drainage systems. Every one of these cities sits at a point in the branching geometry of its mountain-defined drainage system that a mathematician understanding fractal networks could have predicted before a single stone was laid, before a single human being made a decision about where to settle. The root system wrote the address. The civilization moved in. And what this means, what it really means at the deepest level, is that human history is not primarily the story of human choices. It is primarily the story of human beings following a template they could not see and did not know existed, a template written in the geometry of mountains that mirrors the geometry of roots, because both are solving the same problem with the same mathematics. The men who built Rome did not know they were following a fractal branching structure. The merchants who established the Silk Road did not know they were navigating a drainage basin whose shape was mathematically identical to the root system of a tree. The pharaohs who organized Egyptian agricultural production did not know they were operating inside a single drainage channel whose branching geometry was the same as any root in any soil in any garden in the world. They just followed the water. They followed the valleys. They followed the paths of least resistance through the landscape. And in doing so, they traced the geometry of roots without ever once looking at a tree and understanding what they were seeing. The question this raises, and the reason a small number of researchers found it so disturbing when satellite imagery first made the correspondence visible, is this: if the geometry was always there, if it was always mathematically legible to anyone who understood fractal structures, why did it take orbital photography to see it? Why did it take the view from space to reveal a pattern that was structuring all of human economic history? The answer that the mainstream framework gives is simply that no one had the altitude. You cannot see the branching structure of the Himalayas from the ground because you are inside it. You can only see it from above. And before the 20th century, above was not available. This explanation is probably true, but it sits uncomfortably next to a series of anomalies in the pre-modern cartographic record that suggests some prior tradition possessed knowledge of large-scale geographical structure that ground survey alone cannot explain. The Peary Race map of 1513 shows the coastline of Antarctica with features that were not confirmed until the 20th century. Medieval Islamic cartographers produced river system maps of Central Asia that correspond with satellite-confirmed drainage patterns at an accuracy that ground survey methodology cannot reproduce. Ancient Chinese geographical texts describe the continental drainage structure of Asia in terms that only became verifiable with modern technology. These anomalies do not prove that a prior civilization possessed orbital observation capability, but they raise the question of whether the mathematical correspondence between mountain geometry and root geometry was understood at some level by someone, long before the satellite age made it visible to modern science. A civilization that understood this correspondence would have possessed something extraordinary, a predictive model for economic geography, the ability to look at a mountain range and understand, not from experience but from mathematical principle, how the drainage basin it defined would organize the economic life of every civilization that built itself inside it. The ability to understand that the root system wrote the map before the civilization arrived to follow it. That understanding would be one of the most powerful tools in the history of human knowledge. And the fact that it is not present in any surviving text, in explicit form, the fact that it had to be rediscovered from orbital photography in the late 20th century, is either a simple consequence of the limitation of pre-modern observation technology, or it is one more piece of evidence that the process of deliberate historical erasure we have been examining in this series removed something from the record that was once known, something that connected the geometry of trees to the geometry of mountains to the geometry of human civilization, and left behind only the mountains themselves, still branching in their root system pattern, still writing the economic map on the surface of the earth, waiting patiently for someone to gain enough altitude to see what had always been there. The ground beneath us has always been the map. Every mountain range on this planet branches the way the roots of a tree branch, because they are solving the same mathematical problem with the same geometric solution. Every drainage basin defined by those branching mountain ridges has organized human economic life for thousands of years, because the drainage basin is the natural unit of economic organization in a world where water and the valleys it carves are the primary transportation network. Every great city in history sits at a point in the branching structure of its drainage basin that fractal mathematics could have predicted. Every ancient trade route follows the branching lines that mountain geometry defined before the first trader walked them. We did not write the map, we followed it. The mountains wrote it, in the mathematical language of root systems. in the geometry of things that branch, because branching is the only solution to the problem of reaching everywhere from one place. And for all of recorded human history, we walked along those branching lines, built our cities at those predicted points, organized our economies along those fractal templates, and never once looked up far enough to see the root system we were living inside. The satellite gave us that altitude for the first time, and when two photographs were placed side by side on a geographer's desk in the late 1970s, a mountain range from above and a root system from above, the match was not approximate. It was exact. And everything we thought we knew about why civilization developed where it did and how it organized itself the way it did became, in that moment, both confirmed and complicated. Confirmed because the pattern was real and measurable and reproducible. Complicated because the pattern had always been there, and no one had seen it, until someone finally looked from high enough to understand what they were looking at. The question that remains is not whether the correspondence is real. The mathematics settled that. The question is why it took us this long to see it, and whether someone, somewhere, a very long time ago, already had.